So I recently documented my journey to pull energy straight from the atmosphere. And in the video, I actually succeeded. I managed to extract thousands of volts out of thin air, and I used it to power this little Corona motor. These are unique motors which create torque from high voltage static, and they can actually run wirelessly because of it. Well, you demanded a build video like bloodthirsty koalas. Hey! Oh god. Thanks for the lifelong trauma. I think I got the message. So here's how to build the ultimate Corona motor out of acrylic. Hey, I'm Jay. Welcome back to Plasma Channel. After you've learned to make a kick-ass atmospheric motor, consider subscribing and turning on those notifications. Let's get to it. If you're truly a part of Plasma Fam, then you'll be in the acrylic club. That's why the body is made of 2 6-inch discs and 6 tubes 4 inches in length and 3/4 of an inch in width. The rotor is built from a 3.5-inch by 3.5-inch jar mounted on a 2mm wide steel spindle. This slides into 2mm ball bearings, which helps a ton with reducing friction. Other materials include some aluminum tape and various bolts. But what if you don't have acrylic? That's okay, you heathen. Any insulator will work. Now grab an energy drink and fulfill your destiny. Keep the can. First up is the rotor. Find the exact center of the lid. Then, using a bit smaller than 2mm, drill a hole for the rod. Do the exact same for the base. Around the jar's circumference, measure and mark 6 equally spaced sections. For this jar, they're 49mm apart. Cut 6 sections of aluminum tape, which are 75 by 35mm, and round the edges. Then place the tape lengthwise over each mark, being super careful that they're parallel. Now push the rod through and make sure it's balanced. Second step is the acrylic frame. Take both acrylic discs and drill 4mm-ish holes in their centers. Press the bearings into place, making sure that the bearings are snug, but not too tight. Then place 6 equidistant marks around one disc. This actually equals 3.14-inch spacing. Place 1 tube on each mark, making sure the ends of your tubing are at perfect right angles, and glue the tubing into place. Putting it all together, slide the rotor into the bearings on each disc, and glue the second disc into place. Now, this is a small detail, but it's important. The motor frame can't touch the surface it lays on. So I settled on this design, mostly because I really like curves, and I always over-design everything. With a dash of acrylic glue, it gives the motor about a 1/2 inch of clearance, preventing shorts to ground. Frame and rotor combined, it should look something like this. The final step requires some finesse, placing ionization fins. Cut a length of aluminum tape and wrap the center of a tube. Do this for all 6 tubes equally. Every wrapped tube will receive an identical fin. Remember, your energy drink? Well, go Hannibal Lecter on it. Cut 6 sections out of the can measuring 22 by 75mm. Cut these corners. They'll go on the side of the supports and be placed 3 to 4mm from the surface of the rotor. Don't be sloppy Susie like this, or this, but perfectly parallel. Use aluminum tape to connect them to each support and ensure that tape is super smooth. The fin should be angled at 30 to 45 degrees and not touch the rotor. Repeat this for all the supports. All that really remains is to wire up the electrical connections to all the fins, which is just wiring. You don't need to see me do that, but it is really important exactly how you wire the fins. Fins 1, 3, and 5 need to be wired together in parallel, culminating in a power connection. Fins 2, 4, and 6 must be wired in parallel on the opposite side, culminating in a ground connection. Neighboring fins are connected to opposite sides, and you don't need to use any of these bolts, they just kind of help with energy loss. Now, congratulate yourself on the epic mess you've made and the trophy you've built. Then send a picture to my Instagram, because I need friends. Nailed it. If you built the motor right, it should turn static charge into functional rotational motion. And to power this, all you really need is any high voltage DC power source, which personally I just used a little mini Wimshurst machine. With one side of the motor attached to ground and the other side provided a few kilovolts DC, here's what we get. This motor doesn't require much power, so I wanted to see if this would spin if powered by atmospheric electricity. after getting the drone up to about 100 meters, it started turning. It's working, baby. It was going pretty slowly and never picked up much speed, but it still worked. This is really cool. If you want to know the science behind atmospheric electricity and what this drone's doing, check out my last video. And if you think that's cool, it can also turn wirelessly without using any physical power connections. Let me show you what I mean. Well, here's my 400 kilovolt Van de Graaff. As seen from my hair, it creates some pretty epic static charge. Placing a sharp ionization brush on the power bolt, the motor is actually able to turn by extracting energy out of the nearby electric field. I mean, this is fire. With my setup, it was turning well over 3 feet away. Must be magic. I bet that's a form of wireless power you didn't think about. Now, design of these motors is pretty critical, right? My first 2 designs hardly worked at all. The first had too much friction and was just too heavy. It wouldn't turn no matter how much help you gave it. Dead weight. The second design you saw in my video, it worked, however, since it wasn't able to output any torque, it was just more of a visual spectacle. This motor is a legit motor and it looks damn good, but the real beauty lies in the physics involved. Recall that every other fin, like these two, are at ground potential, and the fins in between them, like these two and this one right here, are at a high voltage. Since the foil strips on the rotor are isolated from one another, here's how this works. The negatively charged fins are sharp, so they spray electrons onto the closest foil strip. This causes the strip to be negatively charged and be repelled away, plus attracted towards the positive fin. Once underneath, it transfers the excess electrons plus some more to the positive fin, leaving the strip positively charged. It's then repelled away from the positive fin and attracted towards the negative. This happens to all foil strips and all fins at the same time. Basically, the foil strips act as electron carriers causing rotation. The motor turns push and pull into rotational energy. The torque on this kind of motor isn't particularly high, but I did do a couple of tests just to see what it was capable of. I threw together a stack of washers weighing about 45 grams and tethered it with a string. Well, the motor still turned. That's 45 grams being lifted by the little motor that could. It even picked up speed, indicating that it likely could handle a little bit more. Static charge being used to lift. I mean, really fascinating if you ask me. These are cool little motors. Which is why I made 2. And I'm giving one away to a lucky viewer. To be considered, drop a comment down below and follow me on Instagram or Patreon.
For educational
let me know your
purposes
thoughts
only.
in the comments down below. I've also included links to most
For
of the supplies
entertainment
used in this
purposes
build in the
only.
video description, and I encourage you to please be safe around high voltage. Thank you for watching, and you stay classy.
For entertainment purposes only.